All right, we went deeply into zeros and roots because they're super interesting, but now we have to zoom back out and say, okay, our goal is to connect the algebraic representation of a quadratic function to its graphical form. Okay, so now we know information about the zeros. Yay. Okay, we know that the zeros, roots, x-intercepts are just the values of r such that when we put the values, the value of the root into the function, the output is 0. Okay, but we have a bit more work to do. Okay, we need to find, in addition to zeros, these 5 things. Okay, so for every graph, for every quadratic function, make sure you're finding these 5 things. Okay, so zeros are often easy. We need to find the vertical intercept, the vertex, and that's maybe a new piece of language for us, but all the vertex is it's the highest or the lowest point of the parabola. Okay, and again, the parabola is the visual representation of the quadratic function, and you're either going to have the highest or lowest. So here on this example graph, I've labeled it in purple, but it's just a point that is, in this case, if the parabola is shooting up, the vertex would be the lowest. If the parabola is shooting down, it's going to be the vertex will be the highest point. Okay. So it's one or the other, and you can only have one. Okay. And then there's this axis of symmetry. And so mine kind of looks like it, but if you were to imagine folding along this line, okay, the parabola would mirror itself. It would lie exactly on top of itself. Okay. And that's why it's called a line of symmetry, axis of symmetry, line of symmetry. And so when we write that axis of symmetry, it is an equation of a line, and it is a vertical line, so x equals something. And lastly, we want to make sure to discuss the concavity, which in a rough sense is just the direction of opening. So this green example function would be concave up, so it would open up. Okay. So identify these 5 things as you work through them. But the question is how? Okay, how based on the function itself. Okay. So remember, we have the function f of x is equal to ax squared plus bx plus c. Okay. So first up is finding the vertical intercept. Vertical intercept just means that x is 0. Okay. So we're putting in 0 and we're getting out, in this case, well, that would wipe out, that would wipe out. And so all I'm left with is c. All right. And so then f of 0 is c. So this is literally substitute in 0 for x and figure out what c is. Or if it's in this expanded form versus, say, factored, then you get it for free. Direction of opening. This one is going to be another easy one for us to work with. The quick and dirty rule is that if the value of a is positive, okay, that means that it's going to be concave up. Okay, and so that's an easy way to look at this. Just identify whether that leading coefficient is positive or negative, and down would be is if a is negative. Okay, so a less than 0 opens down, concave up if a is positive. Okay, now to find the vertex, that point, it's a really, well, it's not a really intense process, but we have to use a process called completing the square, which algebraically intense. Look it up on Khan Academy or somewhere. The overall idea is that to find the vertex, you would calculate the x coordinate. So this is saying that x is negative b over 2a, and then the y value would be literally just put in x and get y. Okay, so there we go. Negative b over 2a for x, and then the y value is f of negative b over 2a. Okay, and finally, to find the axis of symmetry, if we look at the graph here, we notice that the axis of symmetry goes through the vertex, right? The x-coordinate of the vertex. So once we find the x-coordinate of the vertex, we've actually found our axis of symmetry. We just say it's the line x is equal to negative b over 2a. All right, so there we go. We know how to find the zeros, vertical intercept, direction of opening or concavity, the vertex, and axis of symmetry. Let's do it in an example. So here's a function. Okay, we want to find the zeros and vertical intercept. Okay, let's start there. Okay, so zeros. Okay, so I'm going to take negative 2x squared plus 4x plus 6, set that equal to 0. Okay, now I have a choice. I can try factoring, or I can do the quadratic formula. Quadratic formula is foolproof, but takes a little bit long. Factoring could go quick. I notice that there's a 2, and in fact, I'm going to factor out a negative 2 out of everything. So I'd get x squared minus 2x minus 3 is equal to 0. And then this would factor further as x minus 3 and x plus 1. Okay, and now I can set each factor equal to 0. The negative 2 would just divide out. So I'd have negative 3 is equal to 0, or x plus 1 is equal to 0, and so x is equal to 3, or x is equal to negative 1. Okay, so that means these are my zeros, so that gives me the points 3, 0, and negative 1, 0. Okay, and I'm going to put those right on my graph. 3, 0, negative 1, 0. Okay, switching colors to find a new thing. Vertical intercept. Okay, also known as the y-intercept. I'm just using vertical because sometimes we don't have y. Okay, so I'm going to do f of 0, which is going to be negative 2 times 0 squared plus 4 times 0 plus 6 just gives me 6. So then I get the point 0, comma 6. There's my vertical intercept. Okay, next up, it says find the vertex and axis of symmetry. Okay, so vertex. This was at negative b over 2a, and then f of negative b over 2a. Okay, negative b, okay, so I might have to remind myself of what the function is. Let's see, it's just this thing. So let's see, it'll be negative, and then 4 over 2 times negative 2. Okay, and then f of negative 4 over 2 times negative 2. And I forgot a negative out in front. Okay, there we go. Doing the calculation, I would get 1, comma, and then f of 1. Okay, and then finally, I'd have 1, comma, and then if I put 1 into the function, I'd have negative 2 times 1 squared plus 4 times 1 plus 6, or 1, and then that'd be minus 2 plus 10, so 8. All right, so I'm going to put the vertex at 1, 8. Let's see, that's 6, 7, 8 right there. And then this also means that the axis of symmetry is the line x is equal to 1. Okay, and I'm going to put that in, I'm going to switch the color to orange and just make a dashed line here. For my axis of symmetry. Okay, and then the last thing that it says to do is graph the function. Okay, it didn't ask me for a direction of opening or concavity. Okay, but I'm just going to make a note that a is equal to negative 2, which is less than 0, so it should be opening down. Okay, that's always an important thing. Now, here, we have almost all the information we need. I would just say use the axis of symmetry when you're graphing to your advantage. The idea of symmetry is that however far you are from that line on one side, you should have another value on the opposite side. So if I'm 1 unit like this away from the axis on the left, then that means I have another dot over on the right. Okay, so then this one I could measure out, okay, I'm 2 away, great. And then I have enough, I know it opens down, so I'm going to make my parabola nice and rounded, something like that. Maybe I want to make that just a little bit better, like that. Okay, and it should roughly fold in half. Visually, when you're graphing these parabolas, make sure that at the vertex it's rounded. It shouldn't be a point. That's one critical thing. Otherwise, make sure to have everything labeled on here, just as I have. If you are doing this free-handed, I strongly advise you to label the points. So like this would be 3, 0, and this would be -1, 0. Label all your points. So 1, 8, 0, 6, 2, 6. Okay, label all the points. It's only 5 of them. It doesn't take that long, just to add clarity to your graph. But otherwise, that is a graph of a quadratic function. And so now we've fully connected the algebraic form to the graphical form. And if you need to, you could always make more values with a table of values, or get more values for graphing via a table. But for now, I think we're good. So there you go. Have fun graphing.